Hello, today is the 21st of July 2012 and I want to talk about polycentric curves. I'll tell you who I am. My name is Angelo Alessandro Mazzotti. I'm a doctor in mathematics and a PhD in operations research, and I'm a high school teacher, mathematics high school teacher in Rome in Italy. And this is one of my videos on polycentric curves. I've been working on polycentric curves in the last months, and you can get to know a bit more about my work on my website, and I'll tell you the complete address at the end of this video. So, what do we mean by polycentric curves? This is a polycentric curve in the sense that it is made of a finite number of arcs of circumference. It's 1, 2, 3, and 4, and they're all connected. Each one is connected to the next one in a smooth way. This point, and this point. By smooth, I mean that the two arcs share a common tangent, somewhere around here, I would say. When they do share a common tangent, they could also have cusps. So, for example, something like this. So this is, you might want to call it polycentric, you might not want to call it a polycentric. To my work, this doesn't really affect anything. But, you have to know that when you share a common tangent, you might have something like this, which I think in English is called a cusp. So in this case you have a cusp here, and a smooth connection here. So, the thing is, how do I find all the possible pairs of arcs fitting the two external ones? So you might want to start from two external arcs and find all the different pairs of arcs. Okay. This is one of the different problems tackled and solved by Felice Ragazzo in his new book on polycentric curves, which I have here. It's called Curve Polycentriche. And I have given mathematical proofs to conjectures, some of the conjectures he talks about in his book, and I have found formulas allowing the drawing of polycentric curves also on professional drawing softwares. These formulas allows complete control on polycentric curves. So I want to show you on this video what the solution to this problem looks like. Again, we have two curves. They are arcs of circumference. They could also be segments. And on each one of them I have a point, and I want to find two more arcs of circumference which are linked together in a smooth way, and each one of them is connect to these two on these points also in a smooth way. So let's see what we can do. What we have here is two circumferences. They were first found by Felice Ragazzo, and I have personally proved what Felice Ragazzo has said on his book, that when you take a point on either of these two, this is the connection point for the two other circumferences. Let us take a look. So I take a point down there, see it, and that is where I draw my circumferences. So the picture here looks a bit messy, but we can get rid of what we don't like, and you'll see what we get. For example, starting from this bit, I can get rid of this bit, then follow the yellow curve, that is getting rid of the green bit. Okay, now we go along the blue one, so I get rid of the brown one, and then this bit here. So this is what we have. We have a polycentric curve with smooth connections in B, in this point that we can call P, and in A. So let's go back and see if we can do something else. We can move along this point because there's only one of the choices. I can choose any point on this circumference. So let us do that and see what happens. See what you get? If I go in this direction, see what happens when I get to this cross. The big circumference becomes a straight line. But I can still use it just as I did before. Get rid of the yellow bit, and so on. So this is also a polycentric curve. We can look at it from a distance. When I get to the other side of this point with a cross, shapes change again. And then when I get to this other point with a cross, the other circumference becomes a straight line. So we get something else. Let's make another choice. Let's get rid of this green one now. This red one here. And the brown one. And this bit here. So you have another polycentric curve here. The only place where you cannot find a polycentric curve is when this point reaches one of the two starting points, that is B. In this case, you don't get a polycentric curve because one of the circumferences has disappeared and the other one is not joined in a smooth way with a common tangent to the rest. You have to skip that point, and you have to skip point A. You get smaller polycentrics in this case here. You can do the same thing. We just figured half of the possibilities you get, because if I go to the next picture, I'll show you what you do if you choose a point on the small one. I'll go through this quite quickly because I think you understood how the thing works. Choose a point P somewhere here, that's the one. And then there's a way of constructing the circumferences. And I'll just move around to show you what you get. There's something for graphics fans here as well, because I find this quite amusing. I have been using Geogebra, which is a software I strongly recommend. The same work can be done on professional drawing softwares, since I have found all the necessary formulas. You can check my other videos on polycentric curves. You can find the list of these videos and information about me on my website www.mazzotti.eu/pcc.asp. And that's it. Thanks again for watching. Goodbye.